Good day, fellow technicians. Oh, this is a little bit. That's better. That's better. So, first live stream from the workshop, actually live in the workshop, rather than a pre-recorded video that I then stream live. So, this is a bit of a strange setup I've got in here. We've got fucking hundreds of cameras going on. If I switch to number 2 here, so we've got a side camera, and we've got the top-down camera for when I'm working on boards, and we've got the scope, and we've got a zoom-in camera for when I'm working on the small parts, a scope cam big, and the Google Chrome if I need to look up any schematics, and you can see them on the screen. So what are we looking at today then? We're looking at a B2 Audio Duo. This is a pretty nice big amplifier, and it's brand new. So this has never been used. This came in from B2, and the customer hooked it up, and it's completely dead. It doesn't even go into protect. There's no protection light or anything like that whatsoever. No operation light. It's just sitting there all dead. So let's have a look. And hopefully this is an interesting video, because this is obviously a brand new amplifier, so nothing's actually blown. So this is pretty cool. We can actually see what's going on with this, and why it fails to turn on, why it's completely dead. And I imagine it's probably going to be something with the remote. So if I probe in the power here, we can see that on the scope, hopefully if this works. Let's turn my scope settings down a bit to 5 and 10 on here, and plug the power supply in. So we can see we've got our 9 volts there waiting ready at the terminal. If we put it into the remote and turn the remote on, you can see that we have our 9 volts on the switch remote here. So the remote is working. However, if we look at the side of the amplifier here, there's no lights on the amplifier whatsoever. It's just completely dead. So this is an interesting one. Let's take the back off and have a look and see why this thing does have absolutely no power going to it whatsoever from the factory. And this is the sort of thing that could happen in shipping. It could have been knocked in shipping quite a bit, and we could have a loose connection inside. Let's have a quick look at the live chat. How's it going, guys? I hope the new format works all right, and I hope the streaming quality is okay. I haven't tested this yet. This is the first test of doing a legitimate live stream with all these cameras. So yeah, let me know how it sounds and how it looks. Mitchell Roberts, this came from a B2 dealer here in the UK. So this obviously has the potential to be a warranty issue, depending on my diagnostic and what I reckon. For the amplifier to have no signs of life whatsoever, it's very unlikely that the customer did anything wrong. If the customer did something wrong and blew the amp, it would be in protection or something. But to have no signs of life whatsoever, that says to me that this is potentially a warranty issue. No, not Blade Ice actually. This one was Team SPB. Team SPB, which is another dealer of B2 in the UK. And so because this is obviously a brand new amplifier, we just want to be very careful with the beautiful white paintwork on here as well. Don't want to scratch it or anything, so made sure I gave the workbench a nice clean before I started. Okay, wicked. Let's have a look inside here, see what's going on. Some people are asking me for some videos on some Class AB amplifiers. Well, here you go, Class AB. A big Class AB. Although I doubt we'll be looking at the output section in this video, because I imagine that we just have some remote issues. So let's get the probe again, and what we need to do is, in cases like this, we need to follow the path of the remote on here, and see this chip here. This chip here is the TL494, and this is responsible for turning the power supply section on and generating all the switching waves for the power supply section. So we need to follow. Plug this back in and follow the remote signal coming into the amplifier and see where it loses it and see what's stopping this thing coming on. Sound is very clear. Thank you. That's good. I was toying with a few different microphones and I wasn't too happy with this one, but it seems to be working all right. Okay. So we're going to go back in here. So this is the remote. So we have the remote power. That's all good. So if we go next to the remotes here, there is a little diode here which will stop anything coming backwards the other way to the remote from the amplifier. So that's working okay. And from there's a tiny little trace that goes off underneath the transformers, la 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 la. That's quite difficult to follow, so I'm just gonna have a look, guess where that goes. It probably comes over here. And so we need to see what's going on at the TL. Oh, hang on, we had a fan spin then. We had a fan spin then. Okay. So the fan spins when you apply the remote. So it's getting some power, but the LED is not lighting up. Okay. Okay. So is the 494 actually working? And it's like just an issue. No. Okay. So the 494. I'm going to use the zoom in camera here so you can see. Whoa. That's where we got this. This is definitely in the wrong location. So if I shift this over a little bit. Is that the right area? Yes, that's the right area. So this is the 494 chip. So this is the chip that generates all the switching waves for the power supply to work on. So we need to check that this is actually getting power. So if we look at pin 1 is just an input for one of the OP amps. So that's not necessarily required. So we've got pin 2 is higher than pin 1. Now on the 494, these should be about the same. They should be the same voltage. Okay, so that might be an issue. Pin number 3 is part of the operation pin. So if this is high, like it is at the moment, you can see you've got 4 volts there on the scope. This thing won't turn on, so that is high. Pin 4 is also to do with dead time control, and that's low. It starts off high, as you can see. I'm just going to push the remote again. Boof. It rises a tiny little bit and then drops down. Let's zoom in a bit on that, like that. So that's working. Dead time control is working, but something is holding this in protect. Pin number 3, that's holding it into protect. Pin 12 is VCC. Yes, it is. We'll get there in a minute. So pin 5, we should have a lovely looking sawtooth wave, which we do. So this chip is operational. So this chip is getting power, and this means it will be getting VCC on pin number 12, 9, 10, 11, 12, which is over here, which it is. That's way off the screen. So yeah, we've got 9 volts on pin 12, and we have a sawtooth wave on pin number 5. So this chip is working, but something is stopping it from turning on. As you can see here, pin 3 is high. Now for this thing to work, pin 3 needs to be low. So the thing is being sent into protection for some reason. It could be a false protection, so it could be like a very small transistor over in this section of the board that is preventing this thing from coming on fully. Or it could be something in the output section which is shorted, also preventing this thing from coming on fully. Okay, so first thing that I want to do on this amplifier is what we can actually do is we can bypass the protection here. So pin 3 we saw on here was high. If we take a small lead and we ground pin 3, that will pull it down low, and it will force the 494 chip to come into operation. And by doing that on a very low current power supply, we can see whether the amplifier then actually does power up fine, or whether something heats up and it struggles to power up due to an issue on the output section or on the power supply section. So that's what we're going to do. I think we'll take a little bit of wire and we shall ground pin 3. Let's find where pin 3 is on the board here. Let's see where ground is and see if there's a ground near pin 3. Mic has changed. Mic has changed. Has it? Maybe if I go to this screen, does the mic change? This one? Ah, crap. Yeah, we've got JVC2. Okay. Thank you very much for that. Futros. I shall. Okay, that should be better now. The microphone should be the same on all screens now. Yeah, wicked. Tomb says I sell B2 for a living. Awesome. I absolutely love B2. It's a fantastic brand. I would love to deal it in the UK, but there's already 2 dealers and a distributor, so that's out the window. So let's find where. Let's see if we've got a ground pin around here somewhere that we can use. We go the other side of a capacitor, that'll probably work. There we go, there's a ground over there, there's one there, and there. There's one right there, that's even closer. Also one there, there. Okay, so there are some grounds that are pretty close. So I think we're going to use this one over here. Pin 7 is ground. It doesn't seem to. There seems to be some kind of resistor in between the ground of the 494 and the actual amplifier's ground. So 1, 2, 3, 4, 5, 6, 7. Oh no, I must have skipped over that with my thing. Okay, wicked. Yeah, but rather than going off pin 7, this little capacitor over here is going to be easier to go off of, so we'll do that. Strip a little bit of cable. I always make my patch cables that I do really big, so that I can see that they're clearly there, and that helps if you've got a few patch cables in an amplifier and the thing starts working again, or you know, you can forget that they're in there and you leave them in, which is not good. So I always make them massive so they're really obvious, so I remember to take them out once I'm finished. Did you see the dyno results of the M15R? No, I did not. Do share. No, B2 is one of those brands that's very high up there for me. I have a lot of respect for B2. I think Jay is fantastic. He's a fantastic businessman as well, and he makes some really nice stuff, and he cares about the quality of the stuff, and he cares about the basshead community. Over 24 kilowatt at 0.5 ohm and 13.1 volts. Wow, holy crap. Can't you turn on some music? Oh, that violates YouTube's regulations. It probably will violate their regulations to some extent, but also when I had music on in a video previously, people complained about it because my taste of music is not necessarily everyone else's taste of music. So yeah, that's epic. That B2 amplifier, that's fantastic results. And I'm happy as well, happy for them. That's wicked. If I wasn't such a DD whore, I'd probably run B2. Or if I could get it for distributor prices. That's the thing, I'm not paying customer prices for things. When I can get the DD at obviously distributor prices. I'm waiting for my flipping, my bloody pointy tip to arrive in the post, because they always die. All the pointy tips for these IOA solder stations always die really quick, and I'm currently waiting for one to arrive. So I'm having to do everything with this bloody huge wedge tip, and it's not easy. Get in there. There you go. There's a tiny bit of solder on pin 3 now, so let's just go in here. That should be enough. There we go. That'll do. What are you doing right now? I am bridging, I'm taking a patch lead and I'm connecting pin 3 of the 494 chip to ground because pin 3 is the shutdown pin for this chip, which is what's preventing this amplifier from turning on because it's high. So something is pulling this pin high, which is stopping the amplifier from coming on. And so what we're doing first of all is we're just grounding that pin so that the amplifier tries to come on. So we're basically overwriting the protection so we can see what the issue is here. It's a brand new amplifier from factory, so I doubt it's got any dead outputs. But let's check for dead outputs anyway. Why the hell not? Let's check for dead outputs anyway. Let's check for dead outputs anyway. So, okay, let's have a look. Let's put this in view. I very much doubt it. I think this is some kind of leaking transistor or something on the 494 area. All the output banks seem fine to me. Nothing is shorted, at least anyway. But the amp's not actually coming on. Like, it's not even pulsing. Like, so the output, the power supply section isn't even giving a small pulse to the output section. So the amp wouldn't even know whether the output section was fine yet. Anyway, the second you apply the remote, pin 3 is just high from the get-go. So it's not even trying to turn itself on. There's something in the power supply section that's dead. What is your daily driver? Car-wise, it's still my old Proton, the yellow thing. I fucking love that thing. Still got it, still going strong. I'm currently rebuilding it at the moment, and I'll do lots of videos on that in the near future, because we're almost done with the SQ build in there. Are those chips common? Seems like people know about them already. Yes, this is the TL494, which is one of the most common power supply IC driver, whatever you call it, PWM generation chips, which are used in car amplifiers. Another one you'll see either a 494, a 594, or a KA7500, and they all work exactly the same. They just generate 2 square waves on pins 9 and 10, which are out of phase with each other, that run the 2 separate sides of the power supply like this, so that it can drive the transformers, which then drives the output section. I'm still waiting on the video where you put better parts in an amplifier, or at least make it more reliable. I will definitely do that, yes. I'm waiting for an amplifier to come in that I own, that I don't care too much about, because yeah, we have the potential to blow it up beyond repair. Especially if we are rewinding the transformers to a higher voltage. Who knows what can happen. So that would be a very fun video, and I'm actually going to keep going with that amplifier until it does blow, because that's a fun thing to do. Okay, wicked. So now we have bridged that, we've grounded pin 3. Let's put our probe on pin 9 and pin 10, and let's see whether this thing starts to operate. There we go. So you saw there on the screen, we had a square wave there on pin, that was pin 9. And pin 10, we've also got a square wave. We've also got now a blue LED, which is lighting up on the amplifier. So what I'm going to do now is take my probe, and I'm just going to make sure that the amplifier comes on fully. So we're going to take our probe and put it on the pin number 2, which is the drain of the power supply MOSFETs. And we should see a nice big square wave come on the screen, and it should stay there. The amplifier should go into full operation. Ta-da! There we go. So the amplifier is in full operation. The power supply is working. That's a nice big square over on the screen. So output section wise, let's have a quick look what we've got going on here. So I mean this power supply that I'm running this on is literally 9 volts and 4 amps, so it's tiny. So if the amplifier was drawing any excessive current due to a fault, then this thing would turn the hell off. So it's definitely not that. Okay, there's definitely no issues. Right, so we've got a minus 44 volts negative rail here on the output section. So minus 44.33, and let's have a look at this other bit over here, minus 44.3. That's fine. Other side, minus 44. Oh, where's the positive one? Is that all the way over this side, maybe? There we go. So 44.86, which is close enough. Let's just have a check on the outputs, on the speaker outputs here. There's no DC, which there is not. So yeah, this amplifier comes on and seems to be working fine. So the issue is in the power supply drive circuit, and there's something that is preventing pin number 3 from being pulled down to ground when the amplifier comes on. So what we need to be doing really is looking for some kind of leaking transistor, or some corrosion on the board, or some a poorly soldered pin to get this up and running again. I mean, some people may decide literally, I mean, this amplifier, you could bypass the protection just by leaving this this wire here. You can make a shorter one, but I'm not going to do that because then the amplifier doesn't have any protection circuit, which is not good. So yeah, we're not going to take the easy way out. We're going to find where the actual fault is, and so get this thing up and running as it should. Harry Richmond says, are you able to modify amps to make them handle stop-start cars voltage systems? What do you mean handle? If you have a car that has stop-start technology, then obviously when you pull up at the lights and put it into neutral, the engine turns off and your voltage then falls back down to 12 volts. So obviously the amp will do less power then. But potentially, if it's dropping down that low to 12 volts and the amplifier is still drawing power, maybe the car will then come back on because there's a current draw. I've not actually run a system in a car with stop-start yet, so it'd be interesting to know how that works. If I would not have my Audison thesis, I would run B2. Yeah, Audison's wicked as well. I want to hear those T-line doors. Yes, the door cards I will be doing a video on very soon. The door cards are in and they are vinyled. Just need to make the handle so I can actually close the door, and the end of the line need to make the flare. Apart from that, they're pretty much done, so the video will be coming very shortly on those. I would totally rock that dangling wire. Yeah. Yeah, for sure. If it was my amplifier, I would as well, but it's not mine. It's a customer's amplifier, so yeah, we're going to do it properly. Car doesn't notice the amp causing a draw. Yeah, just turn off the auto start. To be fair, I always turn off I've driven cars with the auto stop start, and I always turn it off. It drives me flipping nuts. Absolutely drives me nuts. I'll just turn it off. So yeah, let's remove this patch wire now that we know that this thing works. Let's remove this patch wire. And try not to melt these capacitors in the process. Let's go back to this view. So what we're looking for then is, the first thing we're going to do, I mean, this issue could be pretty much anywhere. There could be a whole bunch of things which are either pulling pin 3 up unintentionally or preventing it being pulled down to ground. So the first thing that I'm gonna try and go through is, out of all the components on a board, the most likely ones to fail are the semiconductor components. So that's all the little transistors and diodes. So I'm just going to take my multimeter on diode beat mode, and I'm just going to make sure that there are no shorted little transistors in here that I can see, because like I say, out of all the issues, out of all the things that could fail, this is most likely to be a transistor or a diode. It's unusual from factory, but we've got to start somewhere with finding this fault. So I'm just going to blindly go through every single transistor and just see if there's a short, if there's a dead one, just in case, because this has worked before, literally. If there's a dead semiconductor component, just go through every one of them and just see if you find a dead one. If we don't find a dead one, then there could be a poor solder joint from factory, which is preventing pin 3 from being pulled down properly. And to access that, we'll have to take the board out of the heatsink, which is I'd like to avoid doing if I can, because this is a pretty big board, and this is a very simple issue. So if I can do a top board repair, then that will be ideal, because I'm lazy. Okay, so there's none of these little transistors are dead. So none of these little diodes are shorted either. So, okay. DM1. Okay, right. Let's put our multimeter probe on pin number 3 then, and let's see what pin 3 connects to on the board over here. The trace goes on the bottom side of the board, so I can't see the trace line to see where it goes to. So I'm just going to randomly probe some stuff around here, see if I can find the resistor that it's connected to, or the transistor that it's connected to. And hopefully I'll find it. Oh man. Where are you? Where are you connected to? Stupid pin 3. Don't make me pull the board out. It could be connected to one of these blue capacitors which have the legs on the underside, which means that I won't be able to get continuity from the top. I think it's connected to one of the capacitors. These blue capacitors here, they can be an absolute nightmare, and you see them in a lot of input sections on the preamp over on the other side of the board, especially the sundown, the smaller amplifiers. If you have an amplifier that comes on but and it seems to be fine, but it won't actually output any audio, then what most likely the case is that these little blue capacitors here, they go bad, and they go bad very, very easily. I've done a few sundown amplifiers where these capacitors have been the issue in the preamp section, and replacing them resolves the issue. The amplifier then makes sound again. So we've got similar capacitors over here in this section. So if anything's likely to be dead, I imagine it might be these. I can't seem to find continuity for pin 3 on top of the board, so it could be one of the pins of these capacitors, which is on the underside. So we're going to have to take the board out of the case. Fun times. But if I did want it to stop start, could it be possible so that the amp doesn't shit itself when the starter kicks in and quickly drops to 11 volts? Oh yeah, that's annoying. That's a bit of an annoyance. The only thing I can think might resolve that issue is putting a high value capacitor on the stop-start motor, so that it takes its initial burst from there. So you need it right next to, you need it right close to the starter motor, and that will take like the initial sudden draw off of the main car battery and the car audio battery. So I'd maybe have I'd have two capacitors. I'd have, obviously, you got your car audio batteries in the back of the car, and I'd maybe run a decent sized capacitor in the back of the car as well. I don't recommend running capacitors generally, but where you've got this issue, you need something that can take a sudden burst of current without huge voltage drop. Like an AGM battery has high internal resistance, which is why a voltage drop happens. So if you have a capacitor, something 20 farad maybe, in parallel with the battery, then it will take the initial grunt of the draw. So I'd have a capacitor and a battery up back with your audio, and then I have another capacitor, like a 20 farad, as close to the starter motor as you can get, so that when it's in, when the car is stopped and you've got the lights and it does the auto turn off, then when you put the clutch down and it starts again, it takes the majority of the current from the capacitor, which is next to the starter motor, and doesn't interfere with the voltage at the back with your audio capacitor and your audio battery. And that would probably make it a lot better. I hope your mic will pick up the T-line sounds. I think it will. I've got a very accurate condenser mic. It's actually an RTA microphone, and so far from what I can see, it picks up very good flat response across the board. I think it will pick it up. The only thing you won't get with the TLs on video is you won't get the stereo image, so you won't be able to hear how wonderfully stereo it sounds because I've only got one of these mics. So no, I'm not buying a second one just for that video. Is that plastic casing of the components burnt? What plastic casing? Say what? Is there an opto isolator IC? I don't think so. Any updates on the solid? I've not made my way around to that one yet. These amplifiers all came in way before the solid came in, so yeah, I'll get there. It's not too far off the list to do. Yeah, I'm not a fan of these clips at all. Not like these. I'd much rather that they just made the amp a little bit wider and opted for the screw down clamps onto the heatsink for these FETs, because these clips, I do not like these clips. Now this is the only issue with the live streams, is that this part, taking the clips off, is boring as fuck, and I would always cut this out on video, but oh well. Come on, you bastard. There we go. I mean the plastics of the microchip and capacitor. No, it's just got a little bit of residue there from the solder flux, because I had my iron right up in there, and I soldered a patch lead to pin 3, and I grounded pin 3, which is the shutdown pin of this IC. And pin 3 is high. When this amplifier, when you try and turn it on, pin 3 is high all the time, which means that the IC is being sent into shutdown. The amp thinks there's a fault somewhere. So what I did is I couldn't find a fault anywhere on the board, so because this is a brand new amplifier, it's never been used, so it's unlikely there's a fault. So I grounded pin 3, and lo and behold, the amplifier came on. So the fault is somewhere in the amplifier's power supply PWM generation circuit area. Whew, it's flipping roasting in here. I'm going to turn these heaters down. Is there a better tool for releasing those clips? Well, not really. You can modify an Allen key to give it a flat end, a bit like a flathead screwdriver, but they work perfect. They work perfectly fine, to be honest. It's just a little difficult because they are just on there. They're held on very tightly, so you just need to put some leverage onto it and pull the clips off. So if there was to be made an ideal tool for this job, then it would pretty much be the same as an Allen key. Maybe a little bit longer to give you some more leverage. Okay, so if we look at this one over here. So I can't get this one off because the input board is in the way. So we're going to have to remove the input board first before I can get these last ones here off. It looks like a fantastic amplifier actually in terms of the circuit design. We've got these four here on heat sinks. These are the final drivers that go to the main output transistors, and they're not FETs. So these aren't output FETs. They are just output transistors because they are not MOSFET parts in the class AB. There we go. We've got a ribbon cable connecting this to the main board, and it's on a clip, so we can just unclip that. Awesome. Fantastic stuff. So what I can do is I can leave this here on the heatsink on the main case and take the rest of the board out. Those are quite big MOSFETs. They're not MOSFETs, my friend. Have you ever repaired a Cadence 12K or any Cadence C series amplifiers? Hi from Greece. What's up? Hi from the UK. Hello Greece. I absolutely love Greece. Fantastic. I have not repaired any Cadence because I have never seen one of those in the UK. The UK only has a limited selection of brands compared to a lot of the rest of the world. We do have some stuff, but there's not massive amounts of it. So no, I haven't repaired any Cadence. However, I imagine the Cadence boards are the same generic stuff that's in all the other brands of amplifiers. So I've probably repaired a very similar board to the Cadence 12K, perhaps, but I haven't looked it up yet, so I can't say for sure. So yeah, we've removed all the clips now. So now what I'm doing is I'm taking these output transistors here. What we need to do is we need to pull them away from the edge because they'll be stuck to these thermal pads. And so if you try and ow fuck, just cut my finger. So if you try and remove the amplifier from the case, now you pull all this stuff away with it, and that's not ideal. So we just want to bend them very slightly back away from the edge, so that it will slide out without any resistance from the from these. Yeah, look. Ouch! Stupid thing. Greetings from Croatia. What is your name? My name is Sam. Amazing that this amp is only 3K. Yeah, well, it's a class AB. What do you expect, man? What do you expect? I've actually seen class ABs doing less power that are actually bigger than this. This is not a huge class AB for its size. It's relatively compact. I'm sure some of you will be aware of the Digital Designs S2B. Beautiful amplifier, that. To remind myself how many, I think that was like 2,400 watts RMS, was it? With the two channels combined? And that was a lot bigger than this, I think. That was a lot bigger than this. It was longer. AQ20. Woohoo! Yeah, man. AQ20, but that's not a class AB. The AQ20 is bloody awesome. Greetings from all the way from Southend. Yeah, that's pretty local compared to most of the viewers. Been looking at the FI SSD V3. Want to grab a couple of 12s. Do you think they'd be good on around 15 to 800 RMS with the flat wind, 8 wind leads, cooling vents drilled in? SSD V3, yeah, that should be about the right sort of power for that. It should sound pretty nice. FI are doing fantastic stuff at the moment, actually. Like, I don't know about anywhere else in the world, but in the UK for sure, the FI stuff is kind of hard to beat for the money. Like, they're priced really well, and all the other really, you know, main big brands, Digital Design, Sundown, DC, you know, all that sort of stuff, they're a lot more expensive for the same thing. So, and the FI woofers they're putting out are actually pretty nice at the minute. They've got quite a few nice new Neo designs and stuff going on, and they're always bringing out new revisions of their woofers to stay up to date, and they're very fairly priced. I think they're quite hard to beat. Almost there with these now these power supply MOSFETs, they're almost there. Okay, cool. So we've pulled all the transistors and all the MOSFETs away from the edge. So what now we need to take the main screws out of the middle of the board, and this is a feature which is fantastic. Not all amplifiers have screws on the middle of the board here, securing the board down to the heatsink. And what happens if you don't have these is that the board flexes like this from the middle, and it puts strain on all the legs at the sides and snaps them off. And that's why you'll find vibration damage in a lot of ground zero amplifiers, like the Plutonium range, the 4K, and other ones around that, and also the Vibe Monobox MB4 has issues with vibration and like this. There's quite a few amplifiers which you'd think are, you know, pretty legitimate, well-designed, well-built amplifiers, but they don't have any screws holding the board down to the heatsink in the middle, so they flex like a trampoline and they snap the legs at the side. Ground zero are a nightmare for vibration damage, I've noticed actually. Loads of parts in them are not built that well, and they always snap off. Greetings from Poland. Hi buddy. What's your favourite? Class A, AB or D? Depends what I'm doing, I guess. Like, Class A has a wonderful sound. I love the sound of Class A, but there's no power there. There's no power, so if you want to get loud, then, you know, Class A is not really ideal. I love Class A for mids and highs. I don't think you need a lot of power on mids and highs. If you've got nice, good, efficient speakers, you don't need lots of power on mids and highs, especially if you're listening in a car and you're not trying to project the sound over like an open space. So, you know, if you're listening in a confined area, then Class A is beautiful on mids and highs. For bass, really, a subwoofer is just a big flappy air moving device. You're not necessarily going to notice a lot of difference between Class AB and Class D. So I think a good, well-designed Class D with a high damping factor on subwoofers is nice. Or you could just go for something like a Class GH, a bit like the Crown Macrotech series amplifiers, where they are Class AB on low volume, and then when they get to their highest output, they switch the rails, and it's more like Class D, which is quite a clever design. It's quite a clever way of doing it. Which car speakers do you recommend instead of stock door card components one from Skoda? The manufacturer of the car is not really relevant in deciding what brand of door speakers to go for, as long as they fit your standard locations. Or I would actually recommend doing something different to the standard locations. Dead in the whole of the door. Get the door as dead as you can possibly get it, so that the speaker is more like in an enclosure rather than in free air. And just go for whatever's available in your country, whatever fits your price bracket, and whatever you see good reviews from. There's obviously top brands which are more popular than others, so yeah, take your pick. But there's no specific brand that will fit a specific car, other than you get some brands which do like special BMW factory upgrades where they're made with the correct mounts and stuff to fit in the exact factory locations and be seamless. But apart from that, pretty much any brand that works for you, works with your budget. I like burnt AQ20. Expensive repairs cost. Hello from Moscow. Hell yeah. AQ20 repairs would not be cheap. Would not be cheap. There's a lot of expensive MOSFETs in those. Oh, is that what happened with CT sounds? With vibration damage? I've not worked on the CT sounds before, so... But that's hilarious if that's the case. That's just really stupid basic oversight on the manufacturer's part. I mean, come on, man. You're putting like a board that's a few millimeters thick in a case, and you're putting heavy transformers and capacitors on it, and you're mounting it to a surface which is vibrating 50 times a second. I mean, come on. It's just common sense. You want to fix the middle of the board down, for God's sake. Right, this should slide out now. After all that. Here she comes. Okay, what are we stuck on? Stuck on something. Oh yes, over here we have these. There we go. Slowly, slowly. Don't tell me that there's a ground wire on the underside. I hate it when there's a ground wire on the underside. Please don't be a ground wire on the underside. Oh, there's a ground wire on the underside. So in this amplifier, what there is over here, there are ground wires which are on the bottom of the board, which screw to the bottom of the heatsink. And so to get to those, you have to take this off and slide it that way first, unscrew them, and then slide it back out that way. People don't believe me when I tell them that part of the longest parts of amplifier repair is actually taking the damn thing apart and putting it back together again. They don't believe me. But it really is. Taking the stupid thing apart and putting it back together is probably one of the longest bits of amplifier repair. Unless you've got a headache board. I wish I could buy one of your LW amps. They're fantastic, and you probably can. The LW amplifiers are not unique. They're not a unique board design. They're just a Xenon board design. So from Xenon factory in Korea, and there are a few brands which share the same boards as the LW, albeit they might have slightly different quality, because when you go to Xenon, you ask them to make amplifiers for you. You can specify board thickness, you can specify component level, build quality level, etc. Ampere audio is pretty much as close to LW as you can get. So if you can get Ampere audio in your country, then that would be a good shout, I think. Yeah, if you can't get LW. Right, let's get this plate off. I'm going to have to screw these up a bit. Like the FSD, yes, FSD is another one that shares the same boards as LW, and they're made in Xenon, and they're very, very good amplifiers. There is one FSD amplifier that I know of in the UK, and it's a 5K, and yeah, it slams at 0.5 ohms all day long. It's awesome, awesome little bit of kit. Ah, come on, what are you getting stuck on now? There we go. So now to get these ground wires off, we just have to slide it back the other way. And we can see the ground wires have presented themselves. Sometimes I just unsolder these from the board rather than having to do this, but... Hey, what's up, Mr. Lee Coupland? How's it going in the chat? Nice to see you, buddy. Hope you're well. I hope you're not having any more amplifier headaches. Right, finally, we can get this damn thing out of the case. Okay, there we go. I need a bigger workbench, for sure. Let's put this over here for a moment. Let's get rid of the heatsink. Now this is the thing we want to be careful with. We don't want to scratch it because it is brand new. So let's put this down here safely, over by my to-do pile. Okay. B2 is half Norwegian, half Danish. Good mix. Would you personally go with a DD-M5 or an Ampere 7500.1? I would go for the Ampere, personally. I imagine it's probably cheaper. The DD amps are horrifically expensive for what they are. And the DD amps, they used to be unique. They used to be something special, but to be honest, the board designs are the same as every other damn brand on the market. So I don't know why. I don't know how they can warrant charging extra. The amount extra they do, even if it's a little bit more, it's fine. But they charge, well, especially in the UK, the DD amps are so much more expensive than anything else, and it's the same board. Like, no. Where do you source your JL/amp parts? Same place as everywhere else. RS Components, mk2, DigiKey, Mouser. The JL Audio don't use any special parts really. Just, yeah, pretty much anything that's in the JL/series you can buy from a reputable electronics distributor. I have voltage coming out of my outputs on my monoblock. That sometimes is fine. If your monoblock amplifier is either a full bridge amplifier or it uses a single voltage rail in the power supply section, then what you'll find is you'll have half rail voltage on plus and minus of the amplifier's output terminals when you reference it to main ground. So if you put your multimeter probe on main ground and your positive one on the speaker output plus and minus, you might see like 30, 40, 50 volts, and that's just how the amplifier works. So provided it's not in protection and there's no issue with it, then that actually is fine. That's how it works. What do you think of Audison? Yeah, pretty good. Do like a bit of Audison. Right, let's get started on this. So we've got it out of the case now. So what we're going to do is we're going to flip it over, and I want to have a look at the bottom. I want to have a look at the bottom of the. Oh, come on! Why is my shortcuts in OBS not working? 3. OBS is doing that. Right, here we go. Right. So I want to have a look at the bottom of the board, and I want to see whether there are any poor solder connections from factory, because this amplifier is brand new, so there's no reason really that it shouldn't work. So we want to have a look around the TL494 area and see whether there's any reason that pin 3 isn't getting pulled down. So at first glance, it doesn't look like that there is any immediate issues with the soldering. Can I bring this into view? So we've got the TL494 here. This is where it is on the other side of the board. And pin number 3 is... which one is that? Let's flip it over again. So we've got the start of it there. So we've got 1, 2, 3. So pin 3 is this one here. So as I expected, as I guessed earlier, pin 3 actually goes straight to a capacitor by the looks of it. Yes, it does. It goes to one of those blue capacitors. So those blue capacitors can be an absolute nightmare, and they can just be dead straight from the factory. So that could be one of the reasons why this thing doesn't work. So what we're going to do is we're going to apply some power again. I'm just going to measure the voltage either side of that blue capacitor and see whether that is what's causing the issue. There we go. That flexing the board. Yeah, all boards flex a little bit. It's impossible for it not to, really. This is not a very thick board, actually. I've worked on much thicker boards than this. This is not the thickest of boards, but it is only a 3K. So there we go. So we can see we've got our 4 volts still on pin 3, which we shouldn't have. That should be nada. So let's find out what's going on there. So we've got our 4 volts there on that side of the capacitor, and our 4 volts there, that side of the capacitor. Now where does that go next? That goes over to here, and then it goes here, and then it goes here to pin number 2. Oh no, that's garage. There goes. So that goes over there. Pin number 2. Okay, I think we could have a leaking capacitor here. So we see pin number 2. That has 4.9 volts on it. That is part of one of the error amplifiers of this chip. So if we go here, we still have our 4 volts. Here, here, and here. So we shouldn't have any continuity over this cap because it's a capacitor. So it should be DC blocking. So I don't think it's blocking DC. I think it's just passing that 4.9, 4.8. So I think it's just passing that voltage. So I think this capacitor could be leaking. Let's see if it's completely dead short or whether it's just leaking. Okay, so it's not a complete dead short. So it could just be leaking. Okay, we don't have any resistance on it. We don't have any resistance on it at all. So if it is leaking, it's very minor. So much so that the multimeter can't even pick it up. So the first thing I'm going to do is I'm actually going to remove this capacitor and see whether our 4 volts goes away. If it doesn't, then it could be an issue with the 494 itself. It could have a internal short, which is causing it to be pulled high on pin 3. So if that doesn't work, I'll try taking this capacitor out. If it doesn't go away, if it's actually coming from the 494 itself, then I'll swap the 494 out with a bunch of spares that I've got in here and see whether that resolves it. It's got the bent over leads that touch everything else. Straight trims would have been nice. Looks like the inside of an old crunch amp. Most of the capacitor legs that I see are actually bent over like this on pretty much all the amplifiers that I work on. Is there a second trace under the IC? I don't think so. All the main traces for this section seem to go on the bottom of the board. It's only a 2-layer. I'm very interested in what you find with the 494 IC and any caps. Hyphonics Zeus amp I've been working on is a big headache. A lot of audio interference. That's probably my fume extractor. Yeah, so let's remove this capacitor first and see if the issue goes away. So these legs are actually bent over. So what I'm going to do is pull them up straight so that they just it should fall off the board, or it should just be easily pulled out the board once all the solder's been sucked off. There we go. So we've pulled it up nice and straight. Let's get that one a little bit more straight. There we go. Right, let's get our sucker. I'm just going to apply some flux to the area so that it pulls up into my sucker nicely. There we go. That's fun. That's the second one. Move that away from the edge. There we go. So we should be able to pull that off the board now. You always add a little solder before you remove the old solder. Yes, you do, because the old solder it doesn't like to be sucked out. It doesn't flow very easily. So the new solder has flux in it for a start, which helps. And the new solder is fresh, and it will merge with the old solder and help it all stick together and be sucked up by the sucker. Hey Jay, how's it going? So Jay Holm in the chat, how's it going, buddy? So yeah, we can see what the issue with this is with this board then. From what we can see, it is a potential manufacturing issue. Well, not necessarily a manufacturing issue, but we've got this potential capacitor here that is faulty. What we're doing first is we're just removing the capacitor, which could be dead, could be leaking. I've actually got the amplifier to power up by shorting the shutdown pin on the TL494. To ground. I've shorted that to ground. The amplifier comes on and works perfectly. So there's some issue in this area here, in the area of the board, which is responsible for the protection circuit. So the first thing we're going to do is we're going to remove the capacitor, which is responsible for connecting pin 3 to the rest of the circuit. So that's that capacitor out. Now that capacitor is out, what we can do is we can see if the 4 volts is still present on pin 3, because if it is still present, it means there's an issue with the 494 itself and there's an internal short. If it's not present, then it means that there is something else which is sending the 4 volts to this pin. Interference gone. Yeah, the interference would be my fume extractor on my soldering iron. So, pin 3, let's have a look. Okay, so we still have 4.8 volts on pin 3 of the IC. And that is with the capacitor removed. So there could be an issue with the 494, although there's still 4.8 volts on all of these pads for the capacitor. There's 4.9 volts on one side of it, and there's also 4.8 volts on the other side of it and on the pin. So let's see where that's coming from. So there doesn't seem to be any other traces connected to pin 3. So it must be being pulled up internally on the chip. Pin 4 is dead time control. So pin 4 is responsible for the pulse width modulation on the power supply. So if pin 4 is high, then there'll be either no operation or there'll be like a very low percentage of pulse width modulation, and if it's low, then it'll be full duty cycle, which is 50% in these amplifiers. So that's not the issue. So pin 3 is just being pulled high by something. So the next thing I'm going to do is remove the 494 and see whether there is still 4.8 volts on pin 3. If there is, then it could be a short circuit in the actual PCB itself, which would be a massive headache. So to remove this chip, what we're going to do is we are going to put some solder flux and on all of the legs here, and then we're going to suck the solder out one pin at a time, and then wiggle the legs away from the edges of the holes so that they're not connected anymore, and then we'll pull the chip from the top of the board and it should come out very easy. Do you still have car amplifier hooked up in your house for bass, like your old videos on DD subs? No, I do not. I have. I still run my Technics SUV amplifiers for bass indoors for the home theatre. I have an SUV 650, which is absolutely ample for all my home theatre bass needs. FTI BTL Neo or DD95 ESP-SC. What's your take on it comparison-wise? That's from Miguel. How's it going, buddy? I would say it depends on what your goal is. The FI will drop a bit lower. Putting the SC on the DD woofers, I've noticed from my own testing anyway, it increases your motor force, which actually reduces your ultra low frequency response because the motor holds onto the cone a lot better, which for lows you don't want. You want the motor to let go a little bit of the coil and the cone to overshoot the sine wave as it's playing. So you actually want slightly weaker motor force and a slightly larger coil gap for decent low frequency response, like 20 to 28 Hertz. So the FI is probably going to be a bit better at that. However, if you want accurate music reproduction and you want tight controlled bass across the whole board and efficiency, I'd go for the DD. Sam, you got to check out FI Audio's new N7 mids. I'd love to. I would love to. Yeah, FI are doing some nice stuff lately, and at a good price as well. So yeah, we've removed all the solder there from all those holes. So let's just pry these away from the edge, so that we can pull the chip out nice and safe without pulling any of the vias. Most of them are actually pretty much away from the edge already. Because this is a brand new amplifier, the solder is already very, very good and new, so it sucks up very easily. There we go. TL494 chip you are removing. Correct. That is the chip that I'm removing. It seems to be pulling pin 3 high, which is the shutdown pin, without having any influence on the rest of the board. So the pin 3 doesn't seem to be connected to anything on the board, but it's still being pulled high. So it's possible that it's being pulled high internally due to a fault with the chip. So this should just pull out now. Ta-da! TL494. So it's better to one side because that has the potential to be okay. Now with the 494 chip removed, let's see whether we still have our voltage on pad 3, and we can see here that there's no further traces going to the top of the board here. Where are we? This camera. Here we go. So yeah, pin number 3 is here, and there's no trace to the top of the board for this pin. So the only reason that this would be high is if this pad here is receiving voltage, which is from the capacitor that it's connected to, or whether there's a fault with the chip itself. So let's apply some power and see whether that issue's gone away. I think too that the chip has a dead short. Yeah, it might do. It might do. So, moment of truth then. It's not high. Nothing there. So yeah, the chip was internally pulling pin 3 high. Interesting. Interesting. Let's check pin 12 for VCC. So yeah, pin 12 is VCC, so that's our main power input. So I've got the remote being held on just now. So we obviously should just have power to the chip. And we've got, yeah, input into one of the OP amps over here. That's another thing it could be actually. It could be an issue with one of the inputs to the error amplifiers. You see here, so pins 1 and 2 and pins 15 and 16 are error amplifier inputs. And if any of these are incorrect, if one is much higher than the other, then it will cause pin 3 in the chip to go high because it will be in shutdown mode. So if I put a new 494 chip in and we still have an issue there with pin 3 being high, then we need to look at the error amplifiers here on pins 1, 2, 15 and 16 to see whether any voltage is coming to these that it shouldn't be. And these are sometimes the amplifier designer and the amplifier board sometimes uses these error amplifiers to compare the rail voltages, so that if one rail goes down and drops off, then it will cause the 494 directly to go into protect and stop the power supply from switching. So if there is like a broken solder connection somewhere to either pins 1, 2, 15 or 16, then the chip will think that one of the rails isn't present, and so it will turn off. I'm just going to turn the board over and have a quick look to see, because we've got 7 volts on pin 16, which is one of the error amplifier inputs. I'm just going to turn the board over and see how they've designed this, whether they've designed it with that in mind. So pin 16 we've got 7 volts on, and pin 15 we have not got 7 volts on, and I'm just going to trace it back from pin 15 just to see whether no, so that then goes to that one over here, so that's fine. That's being grounded, that goes to ground as well. Pin 16, let's say, what else we got? Okay, that's also being grounded. So I'm just trying to see where this 7 volts is coming from on pin 16, just out of interest. Okay, so it's not that. So the 7 volts on pin 16 goes to this little via here. Where are we on this camera? So you see there's a small via here. That's where the 7 volts is coming from, or the 7.9 volts, 8 volts is coming from for pin 16, which is part of the error amplifier. And so I need to flip the board over and work out where that is then connected to, because that might be the reason that the chip is pulling pin 3 high, because the error amplifiers are not balanced. Pins 1 and 2 are fine. Pins 1 and 2 are both 0 volts, so that won't be causing it. So if anything is pulling pin 3 high internally, it might be pin 16 being 8 volts. But first things first, let's put another TL494 in, just in case there was a fault with the chip itself. Pin 3 is feedback. It's internally connected to the outputs of amp 1, amp 2. Yeah, it is. Yeah. So that's what I'm saying. If there is an issue with the if there's something that's sending voltage to one of the error amplifiers, because it's the pin 3 is the output of the error amplifier, so that could be why it's being pulled high. I'm just going to change the 494 anyway. Also going to put this capacitor back in, because that capacitor's fine. There's no issue with the capacitor there. H1 Nicholas, yeah, this guy knows what he's talking about on the live chat, as you can see there. So H1 Nicholas is confirming the that pins 1, 2, 15 and 16 will cause pin 3 to go high on the TL494, and we've got 8 volts on pin 16, so that could be the case. Solder in our new 494. Resolder this capacitor. Right, let's see if pin 3 is still high with the new 494. It probably will be, because pin 16 is high. Yep. Okay, so our issue then is that something is pulling pin 16 up to... Oh, that's lower than it was a minute ago. Let's go and have a look. So we've got... Okay. So now with the new 494 in, we've got 5.6 on 16, 4.9 on 15, zero volts on 1, and 4.9 volts on 2. So with the 494 chip out of the board, it was pin 16 that was receiving the voltage, the higher voltage. So if we look back on the board, that little via that I showed you earlier, that's where the 8 volts was coming from with the 494 out of the circuit. So if we turn the board over, we'll find where that's coming from, because that's probably going to be coming from a transistor that's to do with the output section, protection circuit. Where was that via? I think that was this one. There's a couple on the top of the board here. Okay, there it is. So this is our via that's that was sending the voltage there. So it's just behind this IC. You can't see it on the camera because the IC is in the way. And that goes all the way over here to capacitor C. So no, it doesn't. You need to follow the trace. That goes over here to diode D21. So we've got 5.5 volts by diode D21. Let's get this in view so you can see. So on the other side of diode D21, we've got 1.4. So it's not coming through this diode because it's lower on that side than it is that side. So let's go the other way. Let's go back, follow the trace, which is along here, goes behind this transformer, all the way over here, all the way round, right round to this diode over here, DP70. Diode, I imagine that's diode protection 70 perhaps. Now, can I move the board over enough so it's in camera view? Don't think I can. Just about. There, this wire's in the way. So this diode over here, DP70, so it's coming from there. So let's check the other side of DP70. We have 6.1 volts on one side, and we have 5.5 volts on the other side. Let's just make sure that that is not shorted and that there's meant to be voltage coming through there. Where did I put my multimeter? Here it is. Which is the best? David Frederick says, love your videos. Which is the best running mids and highs, Korean AB amplifier or Brazilian amplifier? How much power do you need? What impedance do you need it at? I would say from the Korean style of board, class AB, the B2 audio will be probably one of the best. Fantastic stuff. Genesis also, if you don't need a lot of power. For Brazilian amplifiers, if you're looking at class D and you need a lot of power, then out of all of them, probably the Banda would be the best for running mids and highs. Or I think Taramps have just brought out a new range of amplifiers designed for mid-bass and subwoofers. So if it's mid-bass woofers you're running for, you could check the new Taramps M series out. So DP70 diode is not shorted. So we have a correct diode reading one way, about 540. So that's fine. So where's DP70 getting its voltage from? It's probably one of these little transistors over here. So you can see this section of the board here, I imagine is part of the protection circuit. So there'll be a small transistor here. Let's just see whether this transistor is shorted. Nope. Okay, that transistor is not shorted. So let's flip the board over. Now we know that it's DP70 is where that's coming from for pin 16 of the amplifier. Let's flip that over. And it's getting its voltage here from the middle pin of this small transistor here. So what I'm going to do is fire the board up and read some voltages around this little transistor here. So we have our 6.1 volts on that side of the diode, our 5.5 on that side. You can see here we've got 6.1 on the middle pin of this transistor. We've got very, very small little voltage on the other leg, and another very, very small voltage on the other leg. Okay, there's also another trace which is hidden. Let's see if I can zoom in here. Pull this over so you guys can see what I'm working on over here. Here we go. So this little section here. So this pin here is connected to pin 16 of our 494 chip, which is one of the error amplifiers, which is high, which is causing the 494 chip to go into protection. So We need to work out why. So we've got 6.1 volts over this side. Now this trace goes here, and it also goes off to this resistor here. So this is 6.1, and on the other side of this we have 9.4 volts. This goes around here to this one, 9.4, and over the other side. Okay, so there must be a trace on the top of the board then, because we've got 9.4 volts there. When we go around to this side, 9.4, and we jump over to the other component, that is now low voltage. So there must be a trace on the top of the board as well. Flip it back over. Yes, there is. There's a VIA on the top of the board. So we've got 9.4 volts. Where are we? There we are. So we've got 9.4 volts on there, and there is a small VIA which is just here. Now let's flip the board over again and find where that VIA goes to. And that's this one here, 9.4, and you can see that there is a huge, this zoom camera is not ideal. Too far. Okay, so here we go. So the VIA is here, so you can see there's like a little motorway here of traces. So we need to try and follow that back to here. We've got 9.4 volts. I think that's just our input voltage, 9.4. That's just our input voltage. So there's a transistor somewhere that is sending our 12 volts into the OP amplifier through a bunch of components. This looks a bit wobbly. Can you see that on the scope? I'm not sure how well you can see that. What? Okay. What's going on there? So there's definitely something weird going on here. Where is that wave coming from? Because this is partly to do with the voltage which is being sent to the pin 16 over here. So we need to find where that's coming from, that wave. Because we haven't got any switching waves or anything on the board just yet. It's still in protection. Bad solder joints. Yeah, most likely is bad solder joints. We just got to work out where. I wouldn't run tariffs, period. Little mini balls of fire. No, they're not that bad, you know. They're really not that bad. It's just... they're just not designed for the European and American market. They're designed to be used in Brazil on PA style, high efficiency, high impedance rise speakers. Okay. This is getting weirder and weirder by the minute. So we've got this wave on a D600K transistor over here in the power supply section, which is part of the protection circuit. And there's no switching waves on the amplifier anywhere just of yet. There's no power supply switch wave. There's no... The only wave on the board is this sawtooth wave on pin 5 of the 494. I wonder if it's the same frequency. No, it's not. It's not the same frequency at all. It's much, much lower. So the frequency of this strange wave that we've got on here. My scope can't actually find a frequency for it. 44 hertz perhaps? 44, 50 hertz? So something interesting we can take note of is usually the amplifier should display a protection LED on this board. So this is the amplifier's input board. So the amplifier's in protect, so we should really have a red LED on the protection light. I don't know if that could have anything to do with that. You've got 1.9 volts on the red LED, here, 1.8 volts, so that should be lighting up, you would have thought. I would have thought that would be lighting up. So 1.8 volts here on the LED leg. On the positive, it's not actually making any light at all. Got 1.9 volts on that pin, that's probably the protection LED. But no other voltages anywhere else on the board. Just the 1.9, that's probably for the protection LED. Yeah, I did put the cap back here. Cap is back. Okay, let's bring up, just so you guys can see what goes on with the chip, with the 494 chip here. This is a pretty interesting one to see what's causing that to be pulled high. So what I'm going to do is I am going to pull up my little repair notes and guide here. Oh, I forget it's not on this PC. It's not on this PC, it's on my old one. So on C, repair. Does the board need to be grounded? The board is the board is generally grounded. The ground is grounded. On the Tyrant HD 1200, anyone know the IC on the output section? The HD 1200, it could be a 2092 if it's a little one. I can't remember exactly. It might be a 2092. It could also be a 2010S. Okay, let's have a look. And what we're going to do is we're going to bring up the data sheet for the 494. So we can see what's going on here. So this is the block diagram for the TL494. So as you can see, pins 1, 2, 15 and 16, they are inputs for an error amplifier, and the output of the error amplifier is connected to pin 3. Pin 3 will cause this, if pin 3 is high due to the error amplifiers producing a high on pin 3, will cause the TL494 to go into shutdown, which means it won't output any waves, any of the output waves on pins 9 and 10. So pins 9 and 10, you can see here, the outputs for the oscillator here, we've got an in phase and an out of phase, pin 9 and 10. And that's part of the oscillator. Now pins 5 and 6 will set the oscillation frequency, because that's by the oscillator. Pin 4 is dead time control, so that will control how the pulse width modulation of the wave on pins 9 and 10. So, but if pin 3 is high, none of this will happen. So what we need to do is work out on the board what is causing the error amplifier to throw pin 3 high. On the board, with the new TL494 in place, if we apply some power again. Let's move it back over here. So if we apply some power again, pin 1 is nothing, 0 volts. Pin 2 is 4.9 volts, but the reason pin 2 is 4.9 volts is because it's tied directly to pin 3 on this amplifier. I think 4.9, 4.3, 4.7. Pin 16 is 5.6 volts, and pin 15 is 4.9 volts. So this is a weird issue. Yeah, this one's a bit weird, you know, guys. This one's a little bit weird. What I might do is I might reattach our little pull down wire on pin 3 to force the amplifier to come on, and see which of those voltages remains on pins 1, 2, 15 and 16. Are you using less than 10 volts? Maybe it could be a circuit with low voltage protect. It could be, actually. That's not a bad idea. We could try and fire it up with a higher voltage in the supply. Most of these boards that I've ever... Well, no. Sorry, that wouldn't be the case, I don't think, because it fired up when we grounded pin 3. But let's try it anyway. Okay, let's try it anyway. Let's try giving this thing, rather than 9.8 volts, which I use for all my repairs because it keeps things safe, 99% of boards power up on 9.8 volts. Let's just try our 12 volt supply. Just see if that changes anything. I don't think it will, because when we grounded pin 3 it still came on. But that's not a bad idea. That's not a bad thing to try next. I'm just plugging my little 12 volt supply in. Okay, let's put the board back down. So now I have a 2 amp 12 volt supply. And this little supply probably won't be able to get the amp fired up properly, but at least we can see whether the amplifier is out of protection or not. I don't think this is going to work. I'd love it to. I'd love it to work, but I don't think it's going to work. I think you should ditch this amp and use an Auna amplifier. I do have an Auna on the shelf. I didn't pay anything for it. I'm going to do a board swap. So I'm going to put something very tasty inside an Auna case. Okay, pin 3. Holy shit! For fuck's sakes! No fucking way. No fucking way. Okay, so less than 11 volts is dangerous, Kevin McGill. No. Turning an amplifier on with low voltage is not dangerous. It's actually safer. All of the components are under less stress because the voltages are lower. The issue is when you actually drive an amplifier into a subwoofer with a low voltage, the amplifier will the current demand for an amplifier will be greater because there's less voltage. So let's say your amplifier does 2000 watts at 1 ohm 14.4 volts. So you hook it up to a 2000 watt subwoofer and you expect it to do 2000 watts, and so you turn your gains up to so it sounds good. If your voltage is dropping to like 10 volts, for example, then that amplifier no longer can do 2000 watts. It can maybe only do like 1000 watts, maybe around that, a bit less maybe. So to compensate for that, you'll turn the gains up a bit more because you'll be like, well, what the hell, this isn't very loud. So running an amplifier at low voltage is not dangerous for it. What the problem is with voltage drop, your amplifier clips a hell of a lot earlier. And that's what causes damage, is because people usually run their amplifier into heavy clip when voltage drop is concerned. The low voltage isn't the actual thing that is dangerous for it. So I'm just going to scroll up for a second, because on the chat we had the thing that fixed this amplifier. Where's it gone? Where is it gone? Oh, here we go. H1 Nicholas. Round of applause for H1 Nicholas. So I didn't actually think to check whether this amplifier was unhappy with my normal low voltage current power supply. Seems that it was. It fires up fine on 12 volts. So all of that messing around with the 494 and the capacitor and everything was all for nothing. So if anything, any lesson is learned from today, it's that you should always check. I should always check multiple voltages when an amplifier is failing to come on or show any signs of life. You see, the weird thing is one of the reasons I didn't check that to start with is because that was the issue which was diagnosed to me in the first place. So the customer and the dealer said, this amplifier shows no signs of life, there's no LEDs, it doesn't come on, it's dead from factory. So I was like, so when I got it in here and I plugged in my regular power supply that I always use, my little 9 volt, 9.8 volt 4 amp supply, and it showed the exact same problem, then I was like, okay, well this is an issue there. So then I went and looked for a repair. I didn't for once think that this amplifier might be fine, and to try the 12 volt supply, which I should have done. I should have checked the 12 volt supply at the start, but I didn't, and so we've wasted a lot of time. But hopefully this has been an interesting live stream. Let's see what everyone's saying in the chat. Yep, amplifiers are live. So what we're going to do now is we're going to put the amplifier back together, and what I'm going to do is I'm actually going to stop the live stream for now and put it back together, and then I'm going to start the live stream again and we're going to bench test it and see what power it does. So this is the B2, is this the B2 Duo? Yeah, B2 Duo Class AB, and we're going to see how much power it puts out on the bench. So obviously that's the next stage in the repair, is to make sure that the amplifier is actually happy. It could be a bit of a strange one here. The amplifier could actually have had a dead TL494 chip, and I replaced it, and now it works on 12 volts, and it might not have been working on 12 volts before. We will never know. It's just one of those things. Either way, it's working now, and we have the correct rail voltages. .57 volts on the output here with the 12 volt supply. Yep, we've got all the correct voltages here. So Kevin McGill, what was wrong with it? We don't know. We don't know. There could either have been nothing wrong with it and it just wasn't turning on because of my low voltage supply, which I didn't think to check because the diagnostic was the same issue that I was quoted from the dealer as what was happening when I used my regular 9 volt supply that turns on 99% of car amplifiers. This is the 1% of a car amplifier that doesn't seem to want to turn on 9.8 volts. Fair enough. So I should have checked my 12 volt first. But also it could have had an issue with the 494 chip because I changed it and now it works. So it could be either, it could have always worked from the start, or it could have had a dodgy 494 which we changed and now it does. So let's put this amplifier back together and do a bench test and see what power this makes. Whoa. That was just the rail capacitors grounding themselves, that's fine. No issue there. Does the Protect light work now? Yes, it does. Protect light works fine. Duo mk2. Okay. So yeah, I'm going to pause the live stream for a bit. I'm going to put this back together and we'll do a bench test to make sure this thing fully works as intended. And yeah, so I'll see you guys in a bit.